You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT Fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we will introduce the concept of programming language execution models. Specifically, we will examine the difference between interpreted and compiled languages. Two foundational ideas that explain how source code is turned into instructions a computer can understand. You will learn how these models work, which languages use them, and what features distinguish them from one another. The focus is on understanding the process, not performing it. These concepts are part of Domain 4 of the IT Fundamentals Plus exam and appear frequently in definition matching and feature recognition questions. The IT Fundamentals Plus exam includes questions related to programming languages, not for the purpose of writing code, but to ensure that learners understand how different types of languages operate. You may be asked to match a language to its execution model, recognize what a compiler does, or identify whether a description refers to an interpreted or compiled environment. The exam will not ask you to write or run programs, compile files, or use any programming tools. Instead, it tests your ability to define, categorize, and distinguish execution models based on behavior. A programming language model describes how written source code is translated into machine code that a computer can execute. It defines the steps between writing a program and actually running it. These models influence the speed, flexibility, and structure of how software behaves. Programming languages are typically divided into compiled languages and interpreted languages, with some using a hybrid of both approaches. Understanding these models helps explain why different languages are suited for different types of tasks. A compiled language is one in which the entire source code is translated into machine code before the program is run. This translation happens through a tool called a compiler. Once the compiler converts the code, the result is an executable file that runs directly on the system's hardware. Compiled languages include C, C++, and Go. These languages are commonly used for software that requires high performance and efficiency. The compilation process involves scanning the entire program, checking for errors, and creating a binary file that the operating system can execute. All errors must be corrected before the compiled file will run successfully. After compilation, the resulting file can be run without needing the original source code or compiler present. This makes compiled programs easy to distribute and fast to execute, since no additional translation is needed at runtime. An interpreted language works differently. Instead of converting the entire program into machine code ahead of time, the code is read and executed one line at a time by an interpreter. This means the translation happens during execution rather than before. Interpreted languages include Python, JavaScript, and PHP. These languages are widely used in web development, scripting, and educational tools due to their ease of use and flexibility. When an interpreted program runs, the interpreter reads each line, performs the action, and moves to the next. This allows developers to test and modify code quickly without needing to recompile. Interpreted code runs more slowly than compiled code, but it is easier to debug and change. This makes interpreted languages ideal for smaller projects, automation tasks, and environments where fast iteration is more important than execution speed. There are several key differences between compiled and interpreted models. Compiled languages are faster because they are pre-translated into machine code. They also catch errors during the compilation step before the program is run. Interpreted languages, on the other hand, execute code line by line and allow for quicker changes but may catch errors only during execution. Both models have their advantages, and the best choice depends on the needs of the project. Examples of compiled languages include C, C++, and Rust. These languages are known for high performance and are often used in system-level programming. Interpreted languages include Python, Ruby, and JavaScript, which are popular for web development, data analysis, and quick scripting tasks. Some languages, like Java, use a combination of both approaches and are considered hybrid execution models. the exam may ask you to match a language to its classification. Each execution model offers distinct advantages. Compiled languages are optimized for speed and are typically more efficient at runtime. They are best for applications where performance is critical. Interpreted languages are easier to test, update, and debug. They allow developers to make changes quickly and see results immediately. The IT Fundamentals Plus exam does not evaluate which model is better, but it may ask about their general strengths or use cases. You may encounter several question formats related to this topic. One type may ask you to match a specific language to its model, for example, identifying Python as an interpreted language. Another question may describe how a program is executed and ask whether the description refers to compilation or interpretation. You will not be asked to write code, run programs, or perform actual compiling. The exam focuses only on recognition and classification. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Some languages do not fall strictly into compiled or interpreted categories. Instead, they use a hybrid execution model. This approach involves compiling the source code into an intermediate form called bytecode. Bytecode is not machine code, but it is closer to it than the original source code. Bytecode must then be executed by a special runtime environment known as a virtual machine. This method offers a balance between the speed of compilation and the flexibility of interpretation. One example of a hybrid model is the Java programming language. Java code is first compiled into bytecode by the Java compiler. Then, this bytecode is interpreted by the Java Virtual Machine, also called the JVM, which runs on various operating systems. This allows Java programs to be written once and executed anywhere the virtual machine is supported. Python also uses a form of bytecode in its internal execution process, even though it is typically classified as an interpreted language. In real-world environments, compiled code is used for performance-critical applications. This includes video games, system utilities, and embedded systems. These types of software benefit from faster execution and efficient use of system resources. Compiled languages are also common in operating system development, where tight control over hardware and system performance is essential. These use cases are typically mentioned in the exam as context, not as configuration tasks. Interpreted code is common in web scripting, automation tools, and smaller projects where flexibility is more important than speed. Languages like JavaScript run inside browsers to power interactive websites. Python scripts are often used for automation, system management, and data processing tasks. Because these languages allow for rapid development and easy debugging, they are favored in environments where quick iteration is needed. These examples may appear on the exam to illustrate typical use cases. The IT Fundamentals Plus exam does not require you to know how to use a compiler, define syntax rules, or manage command line tools. You will not need to compile files, link libraries, or troubleshoot programming environments. Instead, the exam emphasizes conceptual understanding, recognizing how code moves from source to execution and what tools are used in each model. You are not tested on coding ability, only on execution model awareness. There are several terms you should memorize to succeed on this part of the exam. These include compiler, interpreter, source code, executable, bytecode, virtual machine, and runtime. Each of these terms relates to how programming languages operate. For example, compiler refers to a program that turns source code into a binary executable. Interpreter refers to a tool that reads code and executes it line by line. These terms may appear in multiple-choice questions or short descriptions. Tools that use interpreters include the Python interpreter for Python, browser-based engines for JavaScript, and shell environments like Bash. These tools read scripts at runtime and carry out commands one step at a time. While you will not need to operate these tools during the exam, you should be able to recognize that they fall under the interpreted model and understand their role in executing code. Tools that use compilers include GCC for compiling C and C++ code, and Visual Studio, which compiles and builds applications for the Windows environment. Although the exam will not test specific compiler commands or tool usage, these tools may be mentioned as examples of environments where compilation is performed. Understanding the difference between interpreter-based tools and compiler-based tools helps reinforce your knowledge of the two models. This concept is part of the IT Fundamentals Plus exam because it supports a foundational understanding of how software runs on computers. Knowing whether a language is compiled or interpreted helps you understand how it is used, what its performance characteristics are, and how errors are handled. This foundational knowledge builds a bridge toward future topics in programming, software development, and information systems management. To summarize, programming languages use compiled, interpreted, or hybrid models to convert source code into executable instructions. Compiled languages convert code into machine-readable format before execution, while interpreted languages translate and run code one line at a time. Some languages, like Java, use both methods to balance performance and flexibility. The IT Fundamentals Plus exam focuses on recognizing these models and matching them to appropriate language types or descriptions. Mastering these terms will prepare you for success in Domain 4 and future programming concepts. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.